have to do is simplify the following expression completely. When I square root 100, does anybody remember what 100 breaks into? It's special. If I can't remember, it only works on this type of number. When I square root 100, I get 10. Because 100 is 10 times 10. That's why the square root simplified is 10. So if I apply that to 25, who knows what 25's value would be? 5, because it's 5 times 5. So you can skip writing it out, but that is why the root goes away, because there are 2 of them. These are called perfect squares. Can anybody think of another number that would be a perfect square? 9, because it's 3 times 3. What else? One more. Perfect square. 4, because 2 times 2. Those are perfect squares. You know, the same number multiplied. For question C, it says solve for x. You will notice on these two that x is in the power. Three to the power of x equals 243. Sorry, I need to sneeze. Okay. If I plug in my calculator 3 to the power of 1, it tells me I get a 1. Not a 1. 3. What? You skipped ahead. 3 squared is 9. 3 cubed is 27. 3 to the 4th is 81. 3 to the 5th is 243. So because my equation matches this problem, x will equal the 5. So let me get my calculator and I'll show you what I did. 3. Then I use this little AV button that puts a power on it. I plugged a 1 in and I said, nope, that's not it. 2, not it. 3, 4, 5, that's it. So my x is a 5. I'm just using my calculator. For question B, x is in the power still. I have a plus 5 here. I don't want plus 5, so I will first get rid of that 5 and move it to the other side. 2 to the power of x equals 256. Then I test. As I test, 2 to the power of 1 is 2. 2 squared is 4. 2 cubed is 8. I'm going to skip a few. I'm going to use my calculator. 8. 256. Okay. 2 to the power of 8 is 256. Because they match, that means my x is an 8. Any questions when x is in the power? No? All right, E and F. There is a little side note to use a comma to separate two answers. I need to be careful on these. So when I have x squared equals 9, if I don't know, I can calculate and solve it by saying if I square root this x, then the square root of 9 on my calculator will tell me it's a 3. Square root button. Or you can use this root button, but you'd have to put a little 2 on it because you're using a square root. It has to have a 2, which would give me 3. Now, when I check, I'm just going to test. Is 3 squared equal to 9? If I plug 3 squared in on my calculator. Is 3 squared equal to 9? Yes, that's why it's a solution. There is one other solution that would work with squared. What if I make it a negative 3? Is it still equal? Does it still equal a 9? Because when I have two negatives, negative 3 times negative 3, they cancel out and become a positive. That is why on this section, my answer will be 3 and negative 3 for my solution. So if I apply that to F over here, when I square root it, x equals 8. Now, because it's a squared, what other number squared would also be 64? A negative 8. All right, I have a cube. There's a 3 on my x. When I solve this one on my calculator, I have to do a cube root to get the 3's to go away. On your calculator, you would want to make sure that you have the little 3 on it with the 512, which equals 8. Now I'm going to test it. I'm going to check. Is 8 cubed 512? Yes, it's good. What if I have a negative 8 in there? Does it equal 512? It's a negative. This one won't work. Who thinks they know y cubed won't have a negative value? It will just be x is 8. Yeah.
Because it's multiplying it 3 times.
Exactly, 3 times. So if I have 3 of them, these would cancel, but I'd still be left. What's another root that would only have a positive value if I had x to another power? What other power would also have negatives left over? What other number would make it so I only have a positive?
5.
5. Good. That would only have one answer. What's another root that would only have one? 7. 9. Any odd number. What would have a positive and a negative power besides, or negative and positive besides just a power of 2? Nope, 25 is odd. 25 would have only 1. 26 would, because 26 is an even number. Even numbers cancel out the negatives. So you can look at the power, it's squared. That means if I have 2 negatives, they would combine and become plus. If I have 3 negatives, it won't work. I would have it left over. So I only have an 8 as my solution. Right, turn your page. We now need to use the graph to write the inequality that represents the shaded region. I am first going to write an equation, then I'll change it to an inequality. First, I'm going to find the y-intercept. Is that positive 5? My slope, I look for another point. I can't go up, so I'm going to go backwards until I find an intersection or a lattice point where they cross on a whole number. You see how it hits at 3 and 1? I would not want to pick any fraction points. This would work. I could pick this point. All of those points work to pick from. From those points, I look for my slope. It is going up 2 and over 1. What is 2 over 1? 2 divided by 1. 2. So my equation would be y equals 2x plus 5. Can anyone fix it? To be an inequality that is shaded down. It is shaded down. That means y is what?
2x is greater than or equal to.
So I just have to change my sign right here. So what was the sign you picked again?
2x is greater than.
Greater?
Oh,
so this is greater?
Yeah.
And do I put a line under it if it's dashed? No line under it. It's a dashed line. So that would be my inequality. Because it is less, y needs to be the smaller, y is smaller than y. Okay. On the right side, my y-intercept is at positive 1. My slope, that's a fraction, that's decimal. Looks like it hits right there. That would be down 1, 2, 3. and over 1, 2, 3, 4. Down 3 over 4. Will that simplify negative 3 over 4? No, so I leave it. My equation, right, if it were just an equation, it would be negative 3 over 4x plus a 1. But I need to fix it to be the inequality. If it is shaded below, that means that the y is smaller than the line. Y is smaller than my line. Because it is dashed, I don't put my equal sign under it. I leave it like this. Bottom left graph, my y-intercept is at negative 4. My slope, as I look through, it hits right there. That means it goes up 1 over 1, 2, 3, 4, 5. Over 5. 1 over 5. The slope has the x on it. My y-intercept is a minus 4. I have to be careful to make sure my sign matches if it's negative or positive. This one was a negative. I then fix, I make it a correction to my equal sign. This one is shaded up, which means y is bigger than my line. Y is greater than my line. And it is solid, so I put my equal sign under. Or my bottom right graph, my y-intercept is negative 1. My slope, this point won't work. It's not right on negative 2, it's just a little bit above it. This point won't work, it's a little bit above negative 3. That one won't work. This one works right here because it's on 4, negative 4. It has whole number values for that point. 1, 2, 3. Down 3 over 1, 2, 3, 4. Y equals my slope with the x on it with a minus 1 at the end. When I fix my sign, I look at my inequality, it's shaded below, so y is smaller than my line, and it is solid. That means I have to put an equal sign under my inequality so I know it's solid. questions on writing the equations? Right, the last three is a review of graphing. To graph this inequality, I look at my sign. It says y is less or equal to, so I will have a solid line and I will shade which direction if it says it's smaller. Down, good. Now I need 2 points for my graph. To find 2 points, I'm going to use my calculator and substitute values in to my equation. 3 times something minus 4. When I plug in a number, somebody pick a value. 0. If I plug 0 in, 0 will be at -4. Pick one more number to substitute in.
1.
1. 1 is at -1. So I plugged these numbers in to my equation, and these are the numbers that my calculator put as outputs. When I graph these, 0 down 4, click. 1 is down 1, click. I then do a solid line and shade below, shade down. Question B. It is going to be a solid line. I shade less, so down. And I'm going to find 2 points. I'm just going to do it in my head. If I plug a 0 in, -2 goes away and you're left with a +3. If I plug a 1 in, -2 times 1 is -2. -2 plus 3 is 1. 0, 3, click. 1 up 1, click. And then it will be solid. I shade down. Why is the last graph more difficult than the first two? It's a little bit different. Yeah. Isaiah?
X on the same side.
Yes. X and Y are on the same side. Does anybody remember what we do when X and Y are on the same side on the left? You have 2 options. We could solve it for Y, so it looks like those two. Or we can find the X and Y-intercepts. Does anybody remember how to find the X-intercept? I'd substitute in a 0 for the Y, which would make it go away. And I would have 5x equals 15. I'm just going to try and look for what would equal 15. what would x have to be? 15 divided by 5 is 3. What about the y-intercept? How would I find the y-intercept? I would plug x in as a 0, which would make it go away. 3y equals 15, which means y should be at 5. Will my graph be solid or dashed?
Solid.
Solid, because there's an equal line. And because it is less, I will shade down. Solid line. Sorry, I'm going to cut off a little bit my point. And I would shade less than the line. If it had been facing the other way, the inequality, if it had been greater, I would then shade up. If this had been a greater sign.